Hello everyone, my name is Abhishek and welcome back to my channel. So I've been telling deployments, CI/CD, rollbacks are super critical for the organizations because a simple configuration change can impact millions of users. This is exactly what happened with recent Microsoft's outage. So on 29th of October 2025, Microsoft Azure experienced critical outage because of a simple configuration change. Unfortunately, this configuration change bypassed their internal validation checks, which led to downtime for millions of users. In today's video, let's understand what exactly is the root cause for this issue, and most importantly, how Microsoft swiftly responded to this issue and brought the system back to normal in just 8 hours of time. So if you're into DevOps and cloud, watch this video till the end so that you understand the root cause, how to mitigate such issues, and most importantly, rollback strategies. Let's get started. So the small configuration change that led to the global outage was related to CDN, Content Delivery Network. Just to make sure everyone understands the reason for global outage, let me start with explaining what exactly is CDN. As per the textbook definition, CDN is globally distributed network of servers that caches content close to the end users to speed up the delivery of the web assets and to improve website performance. Don't worry, I'll make it even easy for you through a real-time use case. Imagine you are working as a DevOps engineer or cloud engineer for an e-commerce application. Let's say you have customers across the globe. You have users in India, maybe in Hyderabad, Mumbai. You have users across United States, Australia, and different parts of Europe. Now, quite obviously, it is very important for your organization to make sure these users located at different parts of the world do not experience any slowness while accessing the website of the application. Because in 2025, if users experience slowness, they move to a different application or alternative application. Now it is your responsibility as DevOps engineer to eliminate the slowness. How do you do that? The most common way to achieve this is to implement CDN for your website. There are two ways how you can do it. Number one, the easy way is just to go to any public cloud platform and use their CDN service. Or number two, the difficult way is to implement CDN on infrastructure of your organization. But for this, your organization should have data centers across the globe, or at least they should have third-party tie-ups with the data centers. Let me tell you how exactly this works. So you should first list down the location of users. So wherever you have users, you have to identify the location, and within those locations, or at least locations that are near to the end users, you have to set up a network of servers. For example, in this case, you have users in Hyderabad, so you have to set up an edge server in Hyderabad. Similarly, in Mumbai, let's say in Perth, Ohio, different locations that are near to your users. And you have to configure these edge servers with routing decisions. You have to configure them with DNS related decisions and how exactly they have to operate when it comes to traffic management. Let me give a very simple example on how CDN works in real time. Imagine you have 100 users in Hyderabad and you have deployed your application on a central server in Singapore along with the static content of your website. So one of your users in Hyderabad, when they access the website of the application, initially this origin server or the main server serves the request of the user. But when you implement CDN, What CDN done is that while providing the user with the website information, it actually caches the static content. So it can be images related to the website or any kind of web assets. It caches that content onto the Hyderabad edge server so that when other users in Hyderabad, let's say 99 other users or even new users, when they try to access the website, request goes to this edge server and this edge server provides them with the static content. That's why these users do not experience any slowness. Now it is up to you. Number of edge servers that you want to configure. More the number of edge servers, more the edge server is near to the user location, the distance users request has to travel decreases. And that can completely eliminate the slowness. So you can have edge server in Hyderabad, Chennai, Mumbai, Perth, Ohio, more locations so that users can pick up the server that is nearest to them, or the nearest server can actually serve the static content to them. And this is what most modern applications do today. Today, when you try to access Amazon.com or Netflix, even from remote parts of the world, you don't experience the slowness because the DevOps engineers in those organizations have configured CDN for their websites. Now, while this looks interesting, let me tell you, it is not that easy to configure CDN by yourself. Because to implement the CDN by yourself, as I told you, your organization should have data centers across the globe, which is very unlikely these days, or at least they have to have third-party tie-ups, which is very expensive. And on top of that, it is not only setting up the servers. Just by setting up an edge server, nothing happens. You have to configure those edge servers with routing rules, DNS rules, and you also have to tell those edge servers how to operate with respect to traffic management. And after doing all of this, you also have to configure something like Cloudflare for SSL termination, or it can be for web application firewall. Overall, this is a quite tedious activity for DevOps or cloud engineers, and it is also cost ineffective solution for the organizations. This is the reason why majority of the companies today, they look for cloud providers and use their managed CDN services. Azure also does the same. So Azure offers a CDN service, a very sophisticated one, which is called Azure Front Door, AFT. And the recent Azure Global outage is actually with respect to AFT. I mean, this service was impacted, which actually led to the global outage. Let's understand that in a couple of minutes. But for now, let's see how exactly AFT works. It is a managed service, just like other services. For example, today, if you look at Kubernetes clusters, you don't have to bring your own infrastructure. You can just go to AKS. You can just tell AKS the configuration that you need. And on the Azure infrastructure, a Kubernetes cluster is created for you. Similarly, you don't have to set up CDN on your servers, but Azure has already set up Edge network, a network of edge servers on Azure data centers. Now, this is a very interesting thing because if you set up your own edge servers, right, you might restrict yourself to some locations, but because Azure is a very popular public cloud provider and they have data centers across the globe, on those data centers and other places, Azure has already configured the edge servers. So the Azure CDN network is very, very robust. On top of that, these edge servers, again, you don't have to manually configure them for routing rules or how exactly should they operate, DNS roles. Everything is done by Azure Front Door. So Azure Front Door acts as a control tower and it tells the worker nodes how exactly they should operate, right? It tells the edge servers how exactly do they need to operate. Now, if you take the same example to understand how user traffic routes with AFT, imagine you have a user in Hyderabad and this user tried to access your website. Let's say example.com slash images slash any PNG file. That is the image file. Now this request from Hyderabad user, understand this carefully, it goes to AFD and AFD uses any cast, right? What happens in any cast? So the DNS of Azure AFD or front door is mapped to multiple edge server domain names. And what AFD does here is that it looks at the location of the user. So in this case, location of the user is Hyderabad. User which initiated this request is from Hyderabad. So Azure Front Door understands, okay, Hyderabad is the location. So it forwards the request to the Azure Edge server. And from the Azure Edge server that is in the Hyderabad, static content is served to this Hyderabad user. Similarly, if the request comes from user in Mumbai, initially it goes to Azure Front Door. Using Anycast, it identifies the location of the user and it forwards the request to the Mumbai Edge server, right? So this is exactly how Azure Front Door works. Two important things. Number one, Front Door acts as a control tower, which tells the edge servers how to operate. Number two, it also uses Anycast to forward the request to the relevant edge server. Now, because front door is very, very powerful, not only end users, that is, people like you and me or organizations use front door to run their applications or to implement CDN, but Microsoft itself also uses front door. So for the Microsoft applications like Azure Portal, the Azure console that you see today also runs behind AFD because Portal is used by people across the globe, right? You can go to a remote village today and access the Azure Portal without any slowness because Portal is running behind the AFD CDN. Similarly, Office 365, Xbox, and even some of the Microsoft databases, they run behind Azure AFD, right? Again, two things. So AFD is used by end users, someone like you and me or our organizations, and even Microsoft uses AFD for popular Microsoft services. So what happened on 29th of October? Now that we understand what is Azure Front Door. So on 29th of October, some engineers in Microsoft, just like how if you are a DevOps engineer in X company, you update the configuration changes of your application. Similarly, Microsoft engineers working on AFT, so they made some configuration changes to AFT. And these configuration changes are told related to the routing rules. So these configuration changes were deployed, but once these changes are deployed, Microsoft realized these changes are actually flawed. Unfortunately, the validation checks got bypassed. So Microsoft says that they have bunch of validation checks, just like how we have CI checks or checks in the CI/CD pipelines. Microsoft also says that they have some validation checks. Unfortunately, those validation checks have bypassed and flawed configuration is deployed. Now, imagine what happens when flawed configuration is deployed to Azure Front Door. It has two major responsibilities. One is control tower. So control tower implementation might have stopped worked. So basically, it provides the instructions to the edge servers and the edge servers might have stopped receiving the instructions. Number two, it also helps the routing So if request comes from the Hyderabad user, this front door forwards the request to the Hyderabad edge server. Now, if front door routing rules are misconfigured, it cannot forward the request to the Hyderabad edge server. It might be forwarding the request to an edge server that is unhealthy. And this is actually from the trusted sources. Some sources says that front door started forwarding requests to the unhealthy edge nodes, and some sources say that Microsoft Azure front door is misconfigured, so it stopped providing instructions to the edge servers, or the edge servers stopped working. Now, when this happens, as I told you, end users applications are also impacted. That is, popular websites, the airline websites that are using AFD or organizations that are using AFD are impacted, and also the Azure portal got impacted. Now, if Azure portal gets impacted, quite obviously millions of users are impacted. Now, if the edge servers are not working, or if the edge servers don't receive the routing request, quite obviously Microsoft portal will go down. And if the portal goes down, everybody who's using Azure portal, or they are using Azure portal for their day-to-day activities, they are completely blocked. And all of this happened because of a simple routing rule change. Now, this change is told to be very, very simple one, but unfortunately, because the security checks have been bypassed and because the flawed configuration is deployed, control tower, which is AFD, has stopped working. Now, what are the key takeaways from this? Number one, security checks or basic CI validation checks are super important for the organizations. No matter how much AI automation you have, you cannot underestimate the AI automation at Microsoft. They might have a lot of validation checks, but still they got bypassed. So it is very important for DevOps and cloud engineers to always make sure, maybe you perform some dry runs, but make sure on your lower environment and also on your production environment, CI checks are always active. And number two, what you can also learn from this case study is that how Microsoft swiftly identified the situation and brought the system back in just 8 hours of time. How did they do it? So they followed the last good state rollback strategy. What exactly is it? Last good state strategy. So when it comes to rollbacks, you have different strategies that you can perform. What Microsoft has done here, so they simply looked at the last successful state. So because this is a configuration file, they might have stored this configuration file in a Git repository. Even if this is a script file, they might have stored this in a Git repository, and they must have reverted the commit. Because Git is a version control system, it has complete history of the commits. They might have simply reverted the commit, and they might have re-triggered the CI/CD pipeline or the deployment. So this means here they might have followed the GitOps approach. Of course, this is not completely clear. This particular information is provided that they roll back to the last good state, but it is not very clear if they followed the GitOps approach or any other approach that they usually follow. There are only two options. One is GitOps or manual approach. So this is how Microsoft has rolled back and brought the system back to normal in 8 hours of time. As DevOps engineers, you should learn about the CI checks and also rollback strategy importance from this outage. Now, as end users, how can you mitigate such things, or how can you help your organization during these outages? Even during the last AWS outage, I explained you can go with multi-region setup, but I clearly explained this is not very important because multi-region setup comes with a heavy cost. So just because there was an outage for 24 hours or there was an outage for 8 hours, you should not go for a multi-region setup. You should actually evaluate the costing. Now, when it comes to the Azure outage, this is actually a global outage, right? This is not a zonal outage or this is not a regional outage, but this is a global outage. That means no matter in which region you have your applications or your website, you are definitely impacted if you are using AFT or if you are using CDN by Azure. So how do you eliminate this? So one thing that you can do is you can set up active passive configuration for your CDN. What is active passive CDN configuration? So you can have your active CDN setup with Azure Front Door, and you can have your passive CDN configuration maybe with other setup like Cloudflare, right? Cloudflare also supports managed CDN service. You can set up maybe Cloudflare as an backup for your active CDN setup. Or maybe you can set up backup on your own infrastructure. But this is a very costly affair. In any case, I would recommend you to wait for some time, see if Azure runs into such outages more often. Only then go for even the active passive setup. While active passive setup can help you during this situation, but understand one thing, these global outages are not very common, right? So this is just for your interview purpose, or this is just for your understanding how to avoid such situations or how to help your organization during such situations. But you don't have to implement this just because of this 8 hours of global outage, because this thing can be very expensive for your organization. Finally, how active passive setup works. So you set up Azure Front Door, which you already have. So you set up CDN with Cloudflare and just keep it as backup. During such outage, just switch your CDN to Cloudflare and use this as your active setup. So this is about the outage root cause and how Microsoft resolved the issue in 8 hours of time. If you have any questions related to this topic, do let me know in the comment section, and I'd be more than happy to engage in conversation in the comment section. See you all in the next video. Take care. Bye bye, everyone.